So we're gonna start by looking over the unit study guide for linear inequalities and systems. So you may be watching this before taking the exam or after taking the exam, in case you need to make up any of these questions. But let's start with the first one. It says solve the following inequality and graph the solutions on a number line. So in this case, all we gotta do is solve the linear inequality. So we would do something similar to when we were solving linear equations. So we have to isolate or leave x by itself in this case. So the first thing we will subtract is this 3. Is the inverse of the positive 3. These cancel. We get 4x is less than 19 minus 3 is 16. We divide by 4. So x is less than 16 divided by 4 is 4. In this case, since we divided by a positive, there's no need to change the sign. Remember, that's the only time we do that is when we divide or multiply by a negative on the last step. So in this case, the answer is all values of x that are less than 4. So in this case, this would be 4, 3, 2, 1, 0, negative 1. 5, 6, 7, 8, 9. It says all of the values that are less than 4. And in this case, does it include 4? Is that also, was this also x is less than or equal to 4 or just less than? So in this case, it would just be less than. So that would be it. Now the next one, we could do something similar. First, we have to distribute here. So 5x plus 15 is greater than or equal to 2x plus 30. Subtract 15 to both sides. We get 5x is greater than or equal to 2x plus 15 minus 2x. We get 3x is greater than or equal to 15. Lastly, divide by 3. Again, this is a positive, so no need to change the sign. So it'll be x is greater than or equal to 5. So in this case, again, this value will be 5, 4, 3, 2, 1, 0, 6, 7, 8, 9, 10. And it's all the values of x that are greater than 5. But in this case, since it was also equal to, right? In this case, we also include the value of 5 as being a potential answer for the inequality. Question number 2 now asks, it says, it's about a Christmas dinner. It says, Mark is getting dinner for his family. Christmas dinner, the budget for dinner is $130. So there's a budget of $130. Mark plans to buy some prepared dishes from a supermarket, and they're telling us the prepared dishes are sold by the pound at $7.79 every single pound here. He also buys, in this case, he's saying 4 bottles of sodas at $2.99 each. Right, so we have to write an inequality that represents the constraints in this situation by using specific variables, right? And we're going to specify what each one of them means in this case. So let's start by doing that first, right? So in this case, they told us that we have a budget of $130. So that's super important in this case, right? We have to ensure that we realize that we have this budget, so we have to take it into account, right? And he's buying certain things. So he's gonna buy some prepared dishes, right? And in this case, they're saying that they're selling those by the pound, and they cost $7.79 per pound. But then he also has to buy 4 bottles, and those are $2.99 each. So in this case, then we could now take this information, and we know again it's gonna have to buy some prepared dishes, so we have to use that first. So 78.79 per pound, so times P, right? And then we have to include the sodas. Well, in this case, they're $2.99 each, so we could do $2.99 time. In this case, we already know they've already bought 4 bottles, right? So that's not an unknown number. It's not like we don't know how many bottles they're gonna buy. In this case, we don't know how many pounds they're gonna buy, so we could leave it as P. But in this case, we know how many bottles they're gonna buy. They're gonna buy 4 of them. So all this amount that they're buying, right, when it comes to the prepared dishes and the sodas, we have to remember that we still have this budget of 130. And we've talked about when we're in a budget, we have to stay below the budget or at the budget. So therefore, this one will be the 779p plus the 299 times 4 has to be less than or equal to the 130. Well, the second question now asks, well, how many prepared dishes can Mark buy, right? Well, in this case, the prepared dishes was represented by this P here. So we have to now solve for that P. So we could already use this equation then to figure out the number of, or the pounds of prepared dishes in this case, right? P. So in this case, we will do 299 times 4. So in this case, we have 299 times 4, and we get, so this we don't change. So 779p plus 1196, which is 299 times 4 is 1196. It's less than or equal to 130. So again, we're just solving here. So 130, right? So in this case, less than 130. So subtract 1196 to both sides. We get 779p. It's less than or equal to 118 with 4 cents. Divide both sides by 779. And that's going to tell us that P has to be less than or equal to, in this case, let me just divide this by 779. And we get that P has to be less than or equal to 15.15 pounds. And in this case, we could have a fraction or a fractional pounds. I mean, we could get like 1.5 pounds, 1.6 pounds. That's based on decimals. So in this case, P has to be less than 15.15 pounds. Question number 3 now says, Monica, an entrepreneur, is selling necklaces at the local event, right? So she's selling necklaces. Monica is. Says it costs her $100 to rent a booth. So that's one of her expenses, okay? The cost of the materials for each necklace, right, is $350. And Monica is selling the necklaces, so she's selling the necklaces for $11. And then it says the inequality 11n is greater than 120 plus 350n represents a situation in which Monica makes a profit. So this inequality here represents where Monica will actually be making a profit. And now the first question says, will Monica make a profit if she sells 10 necklaces? Explain how you know. Well, we already know that the variable that's in the inequality is the number of necklaces. So now we could just substitute this value and see if she actually would make this inequality true, right? So we would do 11 times 10 is greater than 120 plus 3.50n, or 10 in this case. So we get 11 times 10, that gives us 110, is greater than 120 plus, in this case, 350 times 10 is 35. So we get that 110 is greater than 155. So in this case, it is false, right? Therefore, Sorry, we don't even have to. So it's false. So in this case, we could say that Monica will not make a profit. No, would not make a profit in this case, right? So now the second question is asking us to write an equality to show the number of necklaces and that she must sell to make a profit. So in this case, with 10 necklaces, we know she's not gonna make a profit. But now, I actually don't have much room, but I'm gonna do it over here. We could actually use the inequality again. It's greater than 120 plus 350n. So minus 350n to both sides. So we get, in this case, let me just, again, verify. 11 minus 3.5. We get 7.5 is greater than, so 7.5n is greater than 120. Divide by 7.5. You get that n has to be greater than 120 divided by 7 point gives us 16. So that tells us, so again, this was the work for for B, right? So we could say that we could put in order for Monica to make a profit, she will need to sell more than 16 necklaces in this case. Okay, the next question says graphing inequalities in two variables. So this one actually belongs to this graph, and then I don't know why this went up here, but this would represent this graph right here. Y is less than negative 4x plus 8. All right, so I'm going to just scratch this one off over here so it doesn't confuse us. So now, well, how do we graph this? Well, it's very similar again to when we graph linear equations. In this case, it's already in y equals essentially mx plus b form, right? Slope intercept. So 3 here is our slope. So in this case, we'll have 3 over 1 is positive, so it'll be rise over run. And then our starting value here is at negative 4. So in this case, that tells us the y-intercept, right, the start. And now we could graph it, right? So now we could say we start at negative 4. So down here, we're rising 3. 1, 2, 3, running 1. Put in another point. Do it again. 1, 2, 3, run 1. And we could kind of use this now, right, to extend this. My bad. Before we do that, though, actually now we have to remember that if it's less than or greater than, it'll be dashed. If it's less than or equal to or greater than or equal to, it'll be a solid line in this case, right? So in this case, we have less than. So y was less than 3x minus 4, so therefore it's going to be dashed. So in this case, actually, we could do more points. Up 3, 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. And then I could go down right here. 1, 2, 3 down, 1 to the left. Right? And I'll make this essentially like a line, but in this case it's dash. Right? And then now I have to test a point. So in this case, I could test, I'm going to test the point 0, 0 to see if it's a solution. So in this case, I'll have, the point is 0, 0. So I could do 0 is less than 3 times 0 minus 4. 0 is less than, this case is just 0, negative 4. Is 0 less than negative 4? No, that's false, right? So this whole side is false. So therefore, we're gonna shade in on this side, and I'm gonna use this red so that we can kind of see the distinction between the dashed and the shading. So we're essentially shading on the right hand side. So that means that all the solutions inside this region, the red region, are all solutions. Now let's look into this next one. So in this case, we could see that the slope is -4, right? So, sorry, I'm writing really sloppy. -4/1. This is negative, so fall over run. And then we have +8 for the y-intercept. So in this case, I'm going to do this again. So the y-intercept is at +8 now. And then it's falling 4, so down 4. 1, 2, 3, 4. 1 to the right, so it's 1 point. I'm going to do it again. 1, 2, 3, 4. 1 to the right. And again, we can kind of ask ourselves, is it going to be dashed or solid in this case? So in this case, it's greater than or equal to. So we're going to have a solid line in this case. And let me just make that. So go through the points. Extend this over. And then same thing, test the point here, right? So I'm going to test 0, 0 again. And let's check it. So 0 is greater than or equal to -4 times 0 plus 8. So we get 0 is greater than or equal to, this is 0. So 8. 0 is greater than 8. 0 is greater than or equal to 8. False. So again, these are all false here. So that means that we shade in the opposite side. You shade to the right in this case, right? So that tells us that, again, all of these values in here are all solutions or possible solutions to this inequality here. Now let's look at number 5. It says the Saturday market. So it says a vendor at the Saturday market makes a profit, $8 profit on each necklace and a $6 profit on each bracelet. So it says write inequalities to solutions are combinations of necklaces and bracelets you could sell and make more than 120 profit. Okay, well, in this case, we have 2 items. So I'm going to make one X and one Y. And we could see here that the necklaces was X, the bracelet was Y. So in this case, I'm going to have to create the inequality, right? So we have a profit per necklace. So necklaces again was X. So X plus $6 profit for each of the bracelets. So Y. And she wants to make more than 120 profit. So in this case, right, it will be greater than 120. And it says more than, right? It doesn't say that she needs to make more than or exactly 120. So, or it doesn't say at least 120, right? So it means that it's just a greater than. So now we're just graphing the solutions to the inequality. So in this case, we will kind of do it by, again, just like we did it in unit 2. Find the y-intercept by setting x equal to 0 and the x-intercept by setting y equal to 0. So in this case, on this side, we would have a times 0 plus 6y is greater than 120. That cancels, so we get 6y is greater than 120. So we get divided by 6. We get y is greater than 120 divided by 6 in this case, right? 120 divided by 6, we get y is greater than 20 in this case. So for the y, we would be at 20. And then now we have 6y. So we got to substitute for y is equal to 0 now. So 8x plus 6 times 0 has to be greater than 120. That cancels, so we get 8x is greater than 120. Divide by 8 to both sides. And we get the x is greater than, in this case, we get 120 divided by A is actually 15 here. So for the X, this is 12, 14, 16, so it's actually right here in the middle. So we got to be careful. This right here is 14. So now again, I just connect those two, my Y and X intercept. I have that. Oh, my bad. This actually was dashed, right? So we would have to dash it across, right, as best as we can. So we graph this, so check. And then in this, because again, we could test the point, right? We could test 0, 0. So in this case, we have to first realize whether that's a solution or not. So we get A times, so test 0, 0. So A times 0 plus 6 times 0 is greater than 120. So this is 0, this is 0, so 0 is greater than 120. False. So that means that all the solutions are on this side of the inequality graph, right? And then they're asking us if 20.20, 6 is a potential solution. Well, where is that? Where is that, right? Well, if it's in the region, it will be a solution. If it's out of the region, then it will not be a solution. So in this case, the 0.26 is x, y, 20, and then 6 is here, is inside the region. So yes, in this case, right? Yes, 26 is a solution to the inequality. We know this because it was inside the shaded region, right? So in this case, it was within our shaded region. These are all possible solutions here, right? So therefore, that one was inside, so it is a solution. Now let's look at question 6. It says a hairstylist charges $15 for an adult haircut, right? $9 for a child haircut. She wants to earn at least $360 and cut a maximum of 30 haircuts this following week. So it says the following inequalities represent the situation. So they already give us the inequalities. And it seems that they already graphed it too, right? So it says the graph represents the hairstylist constraint. So this says list a coordinate pair that could represent, so again, an x, y, x, comma, y, right? That could represent the number of adults and haircuts that meets both of the hairstylist goals. So in this case, we could see that we have two equations. Obviously, there's blue region, so those are all the solutions for that inequality. And then this shaded like by the lines is another of the inequalities. But it is only here, right, that we need to realize that we have an overlap, right? So this overlap means that it satisfies both inequalities in this case, right? So they're asking us to find one that meets both. So in this case, we could say like 25, 3, for example, right? So in this case, we could say, in this case, that 25, 3 could represent a number of adult and child haircuts that meet both of the hairstylist goals in this case, right? So that's the point. So you could have chosen any point here. You could have said like 25, even this is dark, so 25, 5, 25, 0, right? Like 26, 2, right? Like, or 27, 2, somewhere over here. So there were any of those points that were inside the region for both.